I'll let it be kind of screenshot and post it so you can pause the video and you can see the last part of what the answers are. So the solution for the warm-up kind of deal. Okay? So if you need to see the warm-up, it will be online tonight on eClass. Okay? So let's get into negatives and zero powers. So who can tell me, we know that if we've got 2 to the first power, it just equals 2. What do you think 2 to the 0 power would be?
0.
Jordan? Still not 2, because 2 to the first power is 2. That means you've got a single value of 2 that's happening in a multiplication sequence of bases of 2's. But if we have 2 to the 0 power, so like if we say, hey, this is 2 to the first, we know that that's going to equal 2. And we know that, hey, 2 to the second means that it's going to be 2 times 2. But what if we had 2 to the 0 power? What would that equal? Annie? Not negative 2. Lucy? 1. Because we can't say it would be equal to 0 because there is a base of 2 that's existing. It's just not showing itself. But remember when we talked about, hey, if we did division, if we had 2 to the 5th divided by 2 to the 2nd. So before, when I showed you guys, 2 to the 5th over 2 to the 2nd, I said, hey, that's going to be 2 times 2 times 2 times 2 times 2 over 2 times 2. And I said, hey, you guys can simplify this by canceling these out. But what was left on the bottom? It's not a 0. It's a what?
A 0. A 1.
A 1. That means that there's always an error or a room to be able to multiply by 1 because 1 has that neat property where it does not affect a value. So technically 2 to the first could also be 2 times 1 times 1 times 1 times 1 times 1 because that 1's not going to affect anything, is it? 2 to the second can be 2 times 2 times 1 times 1 times 1 times 1, as many 1's as I want. That 1's not going to affect it. So for here, 2 to the 0 power, there's no 2's existing, but there's always going to be what value that exists? A 1. So no matter what number or base you have, if it's raised to the 0 power, it's always going to be a value of 1. Let's write that rule. Any base raised to the 0 power will always equal 1. It doesn't matter what the base is. It could be a negative base. If it's raised to the 0 power, it'll equal 1, as long as that negative is inside of parentheses. So if I had a negative 4 raised to the 0 power, that's going to be equal to 1. But if I had a negative and then 4 raised to the 0 power, that negative is separate from that 4 to the 0 power, which means we would have a negative 1. Now, for negative exponents, let's say that we had 2 to the 2nd over 2 to the 5th. When I write that out, that becomes 2 times 2 over 2 times 2 times 2 times 2 times 2. And we already talked about how we could go ahead and just simplify. These 2's would cancel each other out. These 2's would cancel each other out. If I have nothing left to cancel, what do I need to put? A 1. So if I write this, then this becomes 1 over 2 to the 3rd power, right? But we know by division, what are we technically supposed to do? Subtract. So this technically is the same thing as 2 to the, what's 2 minus 5? Negative 3. So this 2 to the negative third power is equal to 1 over 2 to the third power. So what happens here when you have a negative exponent, you're going to do the reciprocal, which means you're going to do 1 over, and then the exponent becomes positive. The base remains unchanged. Okay, so here's that rule. When a base is raised to the negative power, the result will be 1 over that base and then the positive power. Always. Base remains exactly as it is. The power just changes to a positive. So if we had 4 to the negative second power, that result will just be 1 over 4 to the second power. But then we can do 4 to the second power, can't we? Right? So it would just be 1 over what? 16. Alright, so I'm going to have you guys try a couple things on your own. What I want you to do is for the next few problems, I want you to write each of them in their simplest form as much as you can using positive exponents to help you, not the negative exponents. I want positive exponents only, so if it's variables, they have to have a positive exponent. If they're numbers, you're going to convert them to the positive exponent and then simplify them as far as you can. Okay? Is that, I don't know if that, can you guys see that that's a negative 4? Yeah. Okay.
Is that negative 3 or negative?
This one?
Yes.
Negative 3. everybody done with 1 and 2? Okay, good, because I'm going to move them up so you can see number 7 and 8. Oh my gosh, she gave us more. It's like she's trying to teach us. Okay, 1 more minute and then we're going to go over it. let's go ahead and go over it. Who can raise their hand and tell me what they got for problem number 1, Kendall? 1/81. Very good. So for here, when you write it, you would have to write 1/3 to the 4th power. Well, 3 to the 4th power is just 3 times 3 times 3 times 3, which is 81. So you get 1/81. Okay, what about for problem number 2? What did you get? Heaven? Huh? 1/4 is correct. Okay, so for here, the first thing you have to do is you're going to subtract your exponents. So you get 2 to the 6 minus 8 power, which is going to give you 2 to the negative 2nd power. Well, 2 to the negative 2nd power is the same thing as 1/2 to the 2nd power, which is going to equal 1/4. Okay? If you get a negative exponent, you got to simplify it to a positive, and then simplify all the way. All right, who can tell me what they got for problem number 3? What answer did you get for number 3? Grant? 1. Okay, so if we go ahead for here, because it's the same bases, we're going to add our exponents. Well, negative 8 plus a positive 8 is going to give us the 0 power, which is just going to equal 1 whole. What about for problem number 4? Elijah?
1/243.
Very good. 1/243. Again, with the exponents, what we're going to do is we're going to add those exponents together, because multiplication means you add the exponents. So that's going to give us 3 to the negative 5th power. But then you got to change this into a positive exponent, so it becomes 1/3 to the 5th power. And then simplify 1/243. Okay, what about for problem number 5? What did you get, Colin? 1/125. Very good. So you would take the multiplication. 1 times 1 is just going to give you 1. And then 5 to the 7th times 5 to the 4th, you're going to add those exponents, so you get 5 to the 7 plus negative 4 power, which gives you 1 to the 5 to the positive 3rd power. And then simplifying that, you're going to get 1/125. Okay, what about for problem number 6? Who can tell me what they got for number 6? Jordan? 1. Okay, so when you multiply here, you're going to add those exponents. So that's going to give you 4 to the 2nd power over 4 to the 2nd power. So now we're going to go ahead and subtract these exponents. So we're going to get 4 to the 0 power when we subtract them, which just equals 1. Number 7, x to the 6th over x to the negative 3rd. Somebody I haven't heard from yet. I'm going to call on you, Olivia. What'd you get? Not x to the 3rd. Lucy, what'd you get? X to the 9th. Okay, so you have to subtract the exponents. You're going to subtract the exponents. So that gives us x to the 6th minus negative 3. Well, 6 minus negative 3 is really the same thing as 6 plus 3. So that becomes x to the 9th power. X to the 9th power. Be very, very careful about that. What about number 8? Somebody, Aristea, what'd you get? Write it in positive exponent form. 1/y to the 12th. Very good. So again, we're going to subtract our exponents. So that becomes y to the negative 4 minus 8 power, which gives you y to the negative 12th power. But now we need it to be written in positive exponent form, so it becomes 1/y to the positive 12th power. Any questions? Okay, I forgot that today was Pride Day for you guys, so I'm going to give you your assignment. You'll work on